Okay, so today we're going to look at parallel and perpendicular lines. So on the little diagram that you can see, we've got two lines, L1 and L2, that are parallel. And we've done this at GCSE, and we all know that the rule for parallel lines is that the gradient is the same. So if we've got the form y equals mx plus c, or the form y minus y1 equals mx minus x1, then it's easy to see if two lines are parallel because they both have to have the same gradient. If we have the form ax plus by plus c equals 0, then we need to rearrange the equation, okay, because we need to work out what the gradient is. So personally, I always go for that form y equals mx plus c, so then I can see what the gradient is. Right, again, something we have done at GCSE, perpendicular lines, but we did it in much less detail. We know perpendicular lines are lines that are at right angle to each other. And the way I talk about this, I'll say the gradient of L1 has to be, and I call it the negative reciprocal of the gradient of L2, okay? So let's have a couple of examples. If we've got y equals 2x plus 3, the gradient of L2 would be y equals, well, what's the negative reciprocal of 2 would be minus a half x. I don't know, plus 1, for instance. Let's do another one. We could have L1, we could have y equals 2/3 x plus 5. And for our L2, we'd have to do the negative reciprocal of 2/3, which would be minus 3/2x plus 1. Okay? And what we always notice is that when we have a number multiplied by its negative reciprocal, 2/3 times minus 3/2, well, that would be minus 6/6, which is always minus 1, okay? Let's try a different one. What happens if we've got 5 times, well, what's the negative reciprocal of 5? Would be minus 1/5. 5 times minus 1/5 would be minus 5/5, which would be minus 1. So sometimes when we're trying to prove reciprocals, it's quite nice to use the rule that the gradient of L1 times the gradient of L2 must equal minus 1. Okay, so when you multiply the two gradients together, then the product of the two gradients is minus 1. So for today's lesson, I'm just going to go through about 5 examples of the type of questions that they could ask you. Okay, so let's have a look. Find the equation of the line that is parallel to the line 3x plus 2y minus 6 equals 0, going through the point 4, 7. So my line is going to have the equation y equals mx plus c. I need to work out what the gradient of the line is, but it's parallel to this line here. So they're going to have the same gradient, which means I need to work out what the gradient of this line is. So how am I going to do that? I've got my 3x plus 2y minus 6 equals 0. I need to turn it into the form y equals mx plus c. So I'm going to add the 6. I'm going to take away the 3x, so I get 2y equals minus 3x plus 6. And then I'm going to divide every term by 2, because I'm going to divide by 2 to get a y equals. So I'm going to get minus 3/2x plus 3. So I have the gradient of my line. And I know the gradient of this line is the same. So my gradient must be minus 3/2. And this line going through, it goes through the point 4, 7. So now, using my y equals mx plus c, or if you wanted, you could use your y minus y1 equals mx minus x1. Let's do that one for a change. So I'd have y minus 4 is equal to minus 3 over 2, because that's the gradient. I'll tell you what, I'll do a bit of highlighting here. So there's my, sorry, made a mistake there, because that should have been y minus 7 equals, because my y value is there, my y1, my gradient goes there, and then my x value goes here, so I'd have x minus 4. Now I can leave it like that, or I can try and tidy it up. How would I do that? Well, I might decide to multiply every term by 2. So because that's in brackets, I'm just going to do that to cancel that 2 there. So I would have, let's get rid of this, 2, get rid of that. 2y minus 14 equals minus 3x minus 4. Expand the bracket, it's going to be minus 3x. Remember, minus times a minus makes a plus. And then write it in the form ax plus by equals c. So I'm going to add the 3x. So I'd have 3x plus 2y minus 14 equals 12. Take away the 12. 3x plus 2y minus 14 take away 12 is minus 26 equals 0. And that's the equation. Right, just out of interest, because sometimes it's nice to show things can be done in more than one way, I'm going to do it with the y equals mx plus c method rather than this, the y minus y1 equals mx minus x1. So my y value is 7, my m was minus 3 over 2, my x was 4 plus c. So I've got 7 equals, well, minus 3 over 2 times 4 is minus 6 plus c. So I'd have 13 equals c. So I've got my equation, y equals minus 3 over 2x plus 13. Need to try and get rid of this denominator, so I need to multiply every term by 2. 2y equals minus 3x plus 26. And then I'm at the same point now, where I've just got to add the 3x, take away the 26, and I'd have 3x plus 2y, take away 26 equals 0. So, two different methods, but you get the same answer. Right, let's have a look at this one. If you want to pause these and have a go at them yourself first, you can do, and then I'll just show you the answer. But if not, here we go. So we want to find the equation of the line that is perpendicular. So perpendicular to the line 4x minus 2y plus 7 equals 0, going through the midpoint of points 2, 7 and 4 minus 1. As soon as we get questions like this, I'll be honest, I probably draw a bit of a diagram because I've got 2 points. So I've got the point 2, 7 and 4 minus 1. So I've got those two because it's quite nice. Oops, sorry, turn my screen off. It's quite nice. I'm going to have to find that midpoint there. Okay, so I'll do that first. So my midpoint is going to be, well, the midpoint between 2 and 4 is 3. I can do that without really doing any proper maths. And the midpoint between 7 and minus 1 is going to be, well, the difference between those is 8. So it's going to be minus 1 plus 4. So my midpoint would be 3, 3. Okay. Now I need to work out what the gradient is. So I want a line. Don't know why my screen keeps going off. I do apologise. I want the line that is perpendicular to 4x minus 2y plus 7 equals 0. So I need to work out what the gradient of this line is. Okay, so I'm going to have to rearrange it. I am going to add the 2y to this side and add 2y to that side. So I get 4x plus 7 equals 2y. Then divide every term by 2. So I've got 2x plus 7 over 2 equals y. So the gradient of my original line is 2. So the gradient of the perpendicular line equals minus a half, because it's that negative reciprocal. Okay, so I want a gradient of a line minus a half. I can sort of like sketch that now, because I know it's going to go through the midpoint M. It's going to have a gradient of minus a half, so it's going to be a downward gradient, quite shallow because it's a half. And it goes through the point 3, 3. So I've got to be honest, my favourite is y equals mx plus c. So it's going through the point 3, 3. So y is 3. My gradient is minus a half. X is 3 plus c. 3 is equal to minus 3 over 2 plus c. So what am I going to do? I've got 3 plus 3 over 2. So that's 9 over 2 equals c. So the equation of my line is, I'm going to go up here, y equals minus a half x plus 9 over 2. Question doesn't ask for it in any particular point, so if I want to, I can leave it like that. If it did say in the form ax plus by plus c equals 0, I'd multiply by 2 and then I would get everything onto one side of the equation. Right, so let's have a look at the third question. Again, if you want to, press pause, have a go, and then see the solution, because this one is a bit different to anything you've seen before, especially part B. Okay, so as soon as the question is like this, where it's talking about 3 different points and triangles, you have to draw a sketch, okay? And it's one of the times when I say be a bit more careful about your sketch, okay? So try and make it not exactly to scale. I'm not saying measure it exactly, but roughly. So if you're going across 2, 4, 6, so mark it out gently. So you've got 2, 4, 6, and of course you need to go back along here. So we're going to have a minus 2 there. And again, I've got to go all the way up to 9. So I'm going to go 2, 4, 6, 8, 10. And actually there is no negative in the y. But I just want to roughly mark it out like this because it will make the diagram a little bit better. So let's put the point A on. So A is at the point 2, 3, so it's going to be about there. So I'm going to put the 3 and the 2 for A. Point B is at 6, 5, which is about there. So that's at 6, and I've got 5 there. And then the point C, let's have a green. We shall have that at minus 1, 9, which is about there. So we've got, oops, minus 1, 9. Okay, minus 1, 9. Prove that the lines AB and AC are perpendicular. So let's put these lines on to begin with. There's AC and there's AB. Right, I'll do AB first, just because it's alphabetical. So, if they are perpendicular, we know that the gradient of AC times the gradient of AB will equal minus 1. So we need to work out the gradients of these two lines. Okay, so the gradient of AB, well, it went from 3 to 5, so it went up 2. It went from 2 to 6 in the x, so it went across 4. So the gradient of AB is change in y over change in x, which is a half. Let's do AC. So again, draw on my little triangle. I went from minus 1 to 2, so I went across 3. I went from 9 to 3, so I went down 6. So my gradient is minus 6 over 3, which is minus 2. So now let's do gradient of AB times the gradient of AC, and that's a half times minus 2, which is minus 1. Therefore, they are, and I do this little shorthand for perpendicular, perpendicular. So I've done part A. I've proved that AB and AC are perpendicular. Now, this last bit, hence find the exact value of tan ABC. So what does that mean? It means if I've got a triangle ABC, so I'm going to draw it in, the angle ABC is this angle here, because it's the angle at B, going from A to B to C. I'll just use a highlighter to show you this. A to B to C. So it wants this angle here. So what it's saying is, show the exact value of tan theta, because I've put a theta there because it's a bit easier to understand. Now, we know, again, back from GCSE, that tan theta is the opposite length over the adjacent length. So looking at the diagram, the opposite length is the length of AC, and the adjacent length is the length of AB. And this is all true because of the fact that this is a right angled triangle. And we know that because we proved that AC and AB are perpendicular. So that means we need to work out those lengths. Right, let's do the first one then. I'm going to run out of space here, but AB is the square root of 4 squared plus 2 squared. And AC is the square root of 9 squared. Sorry, not 9 squared. Is the square root of 3 squared plus 6 squared. Okay, did that there so I could scroll up. So we've got the square root of 16 plus 4, which is root 20. And for AC, we've got the square root of 9 plus 36, which is root 45. And actually, if I simplify these roots, I'm going to get 2 root 5 for AB, and I'm going to get 3 root 5 for AC. So again, we're going back to the original question. What's the exact value of tan ABC, or tan theta as I'm going to call it? It's the opposite length, which was the length of AC, which is 3 root 5 over the adjacent length, which was the length of AB, and the length of AB is 2 root 5. The root 5's cancel. So actually, the exact value of tan ABC is 3 over 2. Okay, quite a complicated question, but hopefully you can see it just goes back to our trig ratios that we learned at GCSE. Tan theta equals opposite length over adjacent length. We're using the how to find the length between 2 points, and we're putting it all together to get the answer. Okay, let's go on to the next one then. So, a straight line L1 with the equation 4x minus y equals 0, and the straight line L2 with the equation 2x plus 3y minus 21 equals 0, intersect at a point A. Find the coordinates of A. Find the point B where L2 meets the x-axis, and hence find the area of the triangle. Right, again, we're going to have to draw this sketch, and at the minute it's difficult to draw sketches when the equations are in these two forms. So I'm going to rearrange both of them before I start. So let's do L1. I'm going to label it L1. So I've got 4x minus y equals 0. Add y to both sides. So I've got my y equals 4x. Okay, so that's a line, goes through the origin with a gradient of 4. Let's have a look at L2. So we've got 2x plus 3y minus 21 equals 0. I'm going to add the 21 and take away the 2x from both sides. So I'm going to get 3y equals minus 2x plus 21. And then I'm going to divide every term by by 3. So I'm going to get y equals minus 2/3 x plus 7. And now I've done that, I can actually sketch these two a lot more easily because I know the gradients and I know where they cross the y-axis. So L1, gradient of 4, really quite steep gradient. So that's y equals 4x going through the origin. L2 crosses the y-axis at 7 and it's the negative gradient, so it's going downhill and it's quite shallow. So I'm going to have to extend my axes. It looks a bit like that. So I've got y equals minus 2/3 x plus 7. And the first part of the question is, find the coordinates of A where these two lines intersect. So this goes back to last lesson. What we do is we say the y value is the same at both of these points. So my 4x must equal my minus 2/3 x plus 7. Denominator makes it quite difficult, so I would multiply every term by 3. So I'd get 12x equals minus 2x plus 21. I would add the 2x to both sides, so I get 14x equals 21, and then divide by 14, 21 over 14, but simplify that, divide both by 7, and you're going to get 3 over 2. Now, so I know that that's 3 over 2 on the x-axis, but I need the coordinates, so I need to work out what the y value is. I would use the simplest equation, which is y equals 4x. So y equals 4 times 3 over 2. 4 times 3 over 2 is just 6. So we know A has coordinates 3 over 2, 6. Okay, so we've done part A, find the coordinates of A. It says the line L2 meets the x-axis at B. So in other words, this is my L2 here. So it meets the x-axis at B. Find the coordinates of B. Well, here, this is the equation of the line. When it meets the x-axis, y is 0. So what I have to do is, I have to say, coming down all the way from here, 0 equals minus 2/3 x plus 7. Okay, because on the x-axis the y is 0. I'm going to add the 2/3 x to both sides, so I get 2/3 x equals 7 multiplied by 3. I get 2x equals 21, so my x must be 21 over 2. So the coordinates of B must be 21 over 2, 0. Okay, so that's 21 over 2. Right, and then the final part. Hence, find the area of AOB. Now, sometimes people can do this question and they can make it a lot more difficult than they have to, because people think I've got a right angle here, so they work out the area of the length of OA. They work out the length of AB, and they use the area of the triangle is a half OA times AB, okay? And that will work, it will give you the right answer, but it's a lot more complicated than you need it to be, because remember, we can use the area of a triangle is a half base times height. And in this case, we know the height of this triangle because the height of this triangle is 6, because we know the coordinates of A. And we know it was 3 over 2 across and 6 up. So in this case, the best way to do this would be to say, and I'll do it in the top corner over here, the area is going to be a half base times the perpendicular height, and in this case My base is the length going across the bottom. So I'm going from the origin to 21/2. So that's 21/2 times the height, which is 6. Okay. So we end up with, put that in your calculator or simplify it by going 1/2 of 6 is 3. So we end up with 63/2. And that is my area. So that's the area of AOB. Right. Next question. Find the distance between the 2 points 2y and 5, 7. Sorry, the distance between the 2 points 2y and 5, 7 is 3√10. Find the two possible values of y. Okay. So, quite difficult to visualise, so I'm going to draw a sketch. So I'm going to draw the point 5, 7 to begin with. So I've got 5, 7 here. And I've got the point 2y, and I'm just going to put it here. I don't know where it is, but I'm going to put it there. And I know that this distance has to be 3√10. So drawing my triangle, the length of this part of the triangle is going to be 3. The length of this part of the triangle, the height of the triangle, is the difference between these two values, which I'm going to write as 7 take away y. And I can use Pythagoras now to solve this problem, because I can say 3 squared plus 7 minus y squared must equal my 3√10 squared. Let's solve this. We've just got an equation now. The only unknown we've got in here is y. 3 squared is 9. Now just be careful. Don't make the classic mistake with this, okay? Remember, a bracket squared means a bracket times itself. So you've got to do 49 minus 7y minus 7y, and then minus times a minus makes a plus y squared. So we've got 49 minus 14y plus y squared equals 3√10 squared. You know, you can put it in your calculator and check, but remember what does that mean? It means 3√10 times itself. Well, 3 times 3 is 9. √10 times √10 is 10. So that becomes 90. Okay. What type of equation is this? It's a quadratic. So the only way to solve quadratics is when they equal 0. So let's tidy this up first. 9 add 49 is 58. Minus 14y plus y squared equals 90. We've got to take that 90 away. So we're going to do 58 take away 90 is 32, or minus 32. Minus 14y plus y squared equals 0. Sorry, I took that 90 away. Right, I'm going to write this how I would normally write a quadratic. Y squared minus 14y minus 32 equals 0. I'm going to see if this will factorise. I think it probably will. So, two numbers that multiply to make minus 32. 132, 2 and 16, and that's the pair we want. So we want minus 16 and plus 2. So y plus 2 multiplied by y minus 16 equals 0. So either y equals minus 2 or y equals 16. So the two possible values of y are y equals minus 2 or y equals 16. So my diagram wasn't great because one of the solutions was at minus 2 and the other solution was at 16. So if I draw that in better, that length is 3√10 and that length is 3√10. Okay. And that was the last question. So have a go at the questions on the worksheet. Again, if you're a bit confused about that tan ABC one, don't worry about it too much. We can have another go at that when we actually start school next year. Okay, but see what you can do, and I'll see you next lesson.